Welcome back. Here is part 2 of graphing exponential functions. So we've done transformations throughout the year, and the parent function that we just did on the other side was, technically it was a times b to the x. Our general form is a times b to the x minus h plus k. All right, so hopefully you remember from earlier in the year when we were graphing, if a is bigger than 1, that will cause your function to stretch. So for example, if a equals 3, your function would look like this. How about 3, Amy? My bad. 3 times 2 to the x. And on these, I'm going to use the parent function of y equals 2 to the x on all of these. If a is between 0 and 1, so a fraction like 0.5 or a half or a third or 3/4, anything along those lines. So let's say if a is a third, this is always going to make your graph compress. Maybe it looks like this: y equals 1/3 times 2 to the x. Your h, so now we're talking up here in the exponent, that will give you your horizontal shift. And remember, your x always lies to you. If you have y equals 2 to the x minus 3, so remember, if it's hanging out with the x, it moves it left and right, and your x lies to you, this is actually going to go right 3. If you have y equals 2 to the x plus 7, your x lies to you, this actually moves left 7. The k, the number off at the end, that will tell you your vertical shift. That means how much did it move the function up and down. This number will also tell you your asymptote. So for example, if I have y equals 2 to the x plus 5, that means it took my parent function and it shifted everything up 5 units. If I have y equals 2 to the x minus 10, that means it shifted everything down 10 units. Let's say we have a combo going on. Let's see if we can identify a, h, and k and tell what it did. So in this particular one, your parent function is y equals 3 to the x. I'll talk about this in a minute. But exponentials are a little bit different, that the parent function is whatever number is right here with your exponent. So the 3 is actually not doing anything. It's just part of my parent. Your 2 is your a, so that means it's going to stretch by a factor of 2. Your 6 is your h, and that lies to you, so that means it's going to go left 6. And the negative 8 is your k, and that means it went down 8 units. And that also tells you your asymptote. I know that I have an asymptote at y equals negative 8. All right, so there's my a, there's my h, there's my k. I didn't put this one on the notes, but hopefully you remember that when you have a negative out in front, that makes it reflect. So this one is going to reflect. The fraction of 1/8, compress, that makes it compress by 1/8. x minus 1, so your x lies to you. That means it went right 1. And that plus 7 off at the end means that your graph went up 7. This number off at the end tells you your asymptote. I know that I have an asymptote at y equals 7 just by looking at it. All right. Let's graph a couple with transformations on them. So your 3 is your A. There's my H. And that plus 1 is my K. This is the parent function y equals 2 to the x. So to figure out what x's I'm going to use, you always look at your exponent and you ask yourself, what would it take to make this exponent add up to 0? Well, that would be 4, because 4 minus 4 equals 0. So once you have this number, we're going to plug in numbers bigger, smaller, smaller. So this is what I'm plugging into my calculator. If you have the Texas Instruments calculator that we've been using, your calculator can handle this whole thing. So you have to type in 3 times 2, and then you need to hit the exponent button, and then do the math. So 2 minus 4 adds up to negative 2, and then hit plus 1, and you know that you did it correctly if you get 1.75. Now we're just going to plug 3 in. So we're going to go 3 times 2. So x equals 3 now. 3 minus 4 is negative 1. Plug that in your calculator, and you should get 2.5. We'll have time to work on calculator skills in class. You plug 4 in, so 4 minus 4 is 0. So that means you're going 3 times 2 to the 0 power plus 1. You should get a 4 there. When x is 5, you have 3 times 2. So 5 minus 4 is 1. Now my exponent is 1. Your calculator should tell you 7. And when x is 6, 6 minus 4 is 2. So you have 3 times 2 to the second power plus 1. And then your calculator should tell you that you have 13. What all transformations occurred? A is 3, so that means it's stretched by a factor of 3. The H is negative 4, so it lies to me. That means it went right 4. And this K is plus 1. That means it went up 1. Is this function a growth or a decay function? So my parent function, or whatever number is being raised to your exponent, that's what you're focusing on right here. So it is all about what is this b number right here. What's the number that's being raised to the exponent? So that's your b. b is 2. If b is greater than 2, I know that this is going to be a growth function. Your asymptote is going to be at y equals 1. And I'll do the others in a minute. So generally, the first thing that I do with my graph is I put the asymptote in so that I know not to cross that line. So I have 2, 1.75, I'm going to estimate. Hey, I meant 1.75, 3, 2.5, 4, 5, 7, and 6. Went off the graph a little bit. Let's see. I'm curious what the y-intercept is. So you could always plug 0 in to find if you want to find your y-intercept. So I did 3 times 2 to the negative 4 power plus 1, and I got 1.1875 in my calculator earlier when I did that. So it's just like right there. So your graph kind of rides along this asymptote line, and then it starts growing really, really fast. If we did an application problem, this would be like the graph of population over the course of time, because population is something that grows exponentially over time. Now I can tell what my domain is. My domain is always negative infinity to infinity. I can plug in any number that I want for x, and it will get me a number. My range. So your asymptote creates a boundary line. Your range is y is greater than 1, which becomes 1 to infinity. So you will never, ever get a value that is 1 or smaller. Now let's graph this one. This time, my parent function is y equals 1/3 to the x power. So we have, that means that's my b. Whatever your parent function is, that tells you if you're going to have growth or decay. So b equals 1/3. 1/3 means that I have a decay function. If you have a decay function, that means that your graph should be going down. It should end up looking like this. There's no a on this problem, so there's no stretch or compress. If there's no number, then that means that there's an invisible 1 in front of it. So there's no stretch or compress with this one. X minus 5. That means my x lies to me, and it went left 5 units. And this minus 2 means that it's going to go down 2 units. So there is my k. Your asymptote is always what this k value is. So I know that I have an asymptote at y equals negative 2. So I'm going to go ahead and sketch that in. All right, let's make a table of values and graph this function. All right, so my middle value of x is whatever it takes to make this exponent add up to 0. So negative 5 plus 5 equals 0. So negative 5 is my middle value. And then from there, I'm going to choose values that are bigger, bigger, smaller, and smaller. All right, so you had to type this into your calculator. So I had 1/3, and then I did the math. Negative 7 plus 5 adds up to negative 2, and then minus 2 to get that downward shift off at the end. And so here's what I really typed in my calculator. I did parentheses 1 divided by 3. I hit my caret key, and I did negative 2. And so since I don't have any parentheses there, it knows that after this that I am like done with my exponent. And then I went minus 2 again. and you should get 7.